Hello student, welcome for a video lecture class on a finite automata. With reference to a previous video, today we will see some more examples on a DFSM where the given language is L equal to AWA, where W belongs to A plus B, means W value may be A or B, and these values may occur n number of time. Check out what is the n value here. N is greater than or equal to 0. So n value is 0 means the W value also become a 0. So no value for W. So when n equal to 0, check out what string you get. You get what? AA. So this is the minimum string in the language. Next, when W equal to 1, that is n value equal to 1, then I can take W, for a W I can take a 1 character. Okay, it may be a or a B. So if I take A for a W, then what string I get? A. If I consider B for a W, then I get what? A. Next, when n equal to 2, so it is A plus B raised to 2. So I can take either of these characters 2 times, okay, for W. So here start and end with the A, this remains same. So W value, here I had taken A for first time and B for second time. So AB is a W value here. Next, I can change this to BA, this is also valid string. Next, the W value may be AA or it may be BB. So when n equal to 2, I can consider a W for W, a 2 characters. The characters may be a same, that is AA, BB or AB or BA. So same thing you do when n equal to 3. So I can take 3 characters for this W. I can consider 3 characters for this W. These characters may be same AAA, it may be BBB or ABA, BAB, any combination you take. Okay. So based on this, I can write a valid strings and the invalid strings in the language. So valid strings are what? The minimum string what I get when W equal to 0, that is AA. So this is the minimum string in the language. Next, AAA is a valid string. So because this is ending with the start and end with the AA. So check out all these strings are start and end with the A. So all these are valid string in the language. Next, write the invalid string also. Invalid strings also. So if a string has a B, then it is an invalid string. If AB is there, so if the string doesn't start with the start and end with the A, then all those strings are considered as the invalid strings for this language. After that, so first step is over. What is the second step? Second step, we should draw the basic DFSM. Okay, basic DFSM. So this basic DFSM depends on what? The minimum string occurred in the valid string list. So what is the minimum string here? It is AA. So 2 characters are there. 2 characters means how many states are required? 3 states are required. So I will write a DFSM of 3 states now. Next, the first state is a start state. I will name this as a Q0. The second state is a Q1 state and the third state is a Q2 state. So I had labeled these states. Next, the first string that you are accepting is AA. So after AA, it should reach what? The final state. So this state I will make as a final state. Next, so I had shown the A transition from Q0 state and A transition from Q1 state. Next, I must show what? The B transitions. Okay, from Q0 and Q1, and for Q2 I must show both the transitions. So if I take a loop for B, then what happen? See, if the string BAA come, check out, it will get accepted by your DFSM if I take a loop for B. So if B come, it will accept and it will be in the Q0 state. When A come, it will change the state. When second A come, it will change the state to Q2 and Q2 is the final state here. So this loop transition is not valid in this case. So back transition I can't give because this is a start state only. Next, in such cases, you are going to introduce what? A trap state, a new state, okay? And that state is, I'll name it as a Q3, okay? So as this is a trap state, after this, if any A's and B's are comes, it will be in the same state, okay? So I had introduced the trap state because I can't give a loop and there is a no other state to show the back transitions, okay? That time I am going to introduce a trap state. Next, I should give the transition, B transition for Q1 state. So check it out for a loop. If I give a loop of B, then what happens? See, the string is started with A. After that, it may contain any number of B's, 0 or any number of B's. If 0 or any number of B's comes, that will be get accepted by this Q1 state. When one more A come, then only it will change the state from Q1 to Q2 and that is the final state. So I can give out I can show the B cut transition as a loop for this. Okay. So next check out. So if I show it doesn't violate, the violation will not occur. Okay. What is the violation here? The string should end with A and B. Okay. It is if I give loop transition. So the strings are accepted where the start of the string is A and the end of the string is A itself. Okay. Next, I must show A and B cut transitions from Q2 state. Okay, if I take a loop for A here, see, you had reached the end, the meaning is what? At least you have what? The one character A at the end only. After that, if any number of A's come, that will be get and accepted by Q2. Okay, so I can give a loop for A. Shall I give a B also here? No. If I give a B, what happen? If B come, then it will accepted by this state. So only A ka transition I can show as a loop. What about B ka transition? So B ka transition I will give back to Q1 state. So if B come, move to a Q1 state, except here any number of these. So whenever A come, then only it will move to a final state. So if B come, what happen? It will reach the Q2 state. When B come, it will move back to the Q1 state. After that, if A come, then only it will reach the final state. Okay. So this is the DFSM to accept the language where the starting and ending character of the string are A. The string start with A and end with A. Okay. So trap state I had introduced because I must show the transitions for A and B from each of the state. Okay. So here loop I can't take, I can't give the back, I can't show the back transitions. So that time I introduce a trap state. Next, you should represent this by using a 5 tuple. So what is the first tuple? That is K. How many states are there? Q0, Q1, Q2, Q3. 4 states are there. Then what is the summation? The alphabets in the language. So what are the alphabets in the language? A or B. So alphabets are already given. A or B it is. Next, what is the start state here? Q0 is a start state. What is the final state? The final state is Q2. And what is the transition function? The transition function always mapped by taking the states and the input symbols. Next, I should map these states with the input symbol. So Q0 of A, where I go to Q1 state. Q0 of B, I will move to a Q3 state. Q1 of A, I will move to a Q2 state. Q1 of B, it is a self loop, so I will be in the same state, that is Q1 state. Next, Q2 of A, it is a self loop, so it will be Q2 only. Q2 of B, I will move to a Q1 state. Q3 of A, I will be in the same state, so I will write here Q3, Q3. So this is a solution for a given language. Next, we will see one more example. So the language given is L equal to W. W belongs to A, where W has odd number of A's. Okay, so first you recognize alphabet in the language. So alphabet in the language is what? It is A only, because W belongs to A, they had given. So W is nothing but a string, and string is made up of what? A only. So only one alphabet is there in the language. So I had written a value for summation here. Next, what is the second condition they had given? Where W as an odd number of A's. So W is nothing but a string, and string is made up of odd number of A's. Odd number of A's means A should occur in a odd numbers. Means 1A, 3A, 5A, 7A, 9A are accepted here. So I'll write the valid string list first. The first step. So valid string list contains what? 1A, next 3A, check out the occurrence of A here, it is odd in number. Next the 5A's, next 7A's, and so on. Next the invalid strings. Invalid string equal to the empty string 2A, 4A, 6A, and so on. So these are the invalid strings. Next, I should draw out the basic DFSM. So basic DFSM depends on the minimum string occurred in a valid string list. So minimum string occurred is A. So I will draw the basic DFSM. So after accepting A, I will reach the final state. Okay. So here the state names are Q0, here it is Q1. Okay. So I must show a one transition from each of the state, because there is only one alphabet in the language. Okay. So here Q0 of A already I had shown. If 1A come, it will move the final state. What about 3A's? Shall I show the loop here? If I show the loop for A, what happened? What happened? It accept 1A, if 2A come it will accept, if 3A come it will accept, if 4A come it will accept. So I can't show the loop. So what is the next step? Shall I show the back transition to the start state for this A? See, check out. If I show the back transition, check it out. If 1A come, it will move to the final state. Next 2A come, it will move back to a Q0 state, where Q0 is a non-final state. So it will not get accepted. So if 3A come, it will move to the final state. 4A, 5A, 6A, 7A, next 8A, 9A, and so on. So it starts accepting what? The odd number of A's. Odd number of A's. So I have to show only one transition from each of the state, because the alphabet in the language is A only. So from Q0 state I had shown the A ka transition, from Q1 state I had shown the A ka transition. So 1A, 3A, 5A, 7A's are start accepting from this DFSM. Next, I should represent this by 5 tuples. So summation equal to A, only one alphabet is there. States are Q0, Q1. Start state is Q0. Accepting state is Q1. Next, the transition function I should write here. So only one character and two states, Q0, Q1. Q0 of A I will reach Q1. Q1 of A I will reach Q0. So this is a transition table. I hope you understood both the problems. Thank you. If in the exam they ask a question like L equal to W, W belongs to A plus B, where W has an odd number of A's and B's. Then a little modification you are going to do in this DFSM. So here what will be the summation value? A comma B. So the valid string list may contain a single A or a B. Next, 3 A's or 3 B's. Next, ABA is also valid because the count of this string is 3. Next, B is also valid because the count of this string is 3 and 3 is odd in number. Next, the 5 A's, 5 character in the string may be A, B, okay. So these are the valid strings. So only the modification that you are going to do in this DFSM is, instead of A, you are going to give A, B ka transition. You are going to show both transition. If A or B comes, then you are going to change the state from Q0 to Q1. Here also you are going to give A comma B. If either A or B comes, then you are going to change the state from Q0 to Q1. So check it out. If B comes, it will change the state from, check out whether this is accepted or no. If B comes, it will change the state from Q0 to Q1. So that is the accepting state, so it start accepting this. If 3 B's come, so 1B, 2B, 3B, start accepting. Next, ABA, if 1A come, it will read that A, it will change the state from Q0 to Q1. If B come, it will change the state from Q1 to Q0. Next, when the next A come, it will change the state from Q0 to Q1. So it start accepting the string which is 3 in the size. So this is about the DFSM which display strings of A's and B's. The number of the count of string is odd in number. Check out the next example where L equal to W. So L is made up of a string W, where the length of W, the mod of W indicates the length of W, the length of string mod 2 equal to 0. The length of string mod 2, so when you divide the length of the string by 2, the remainder should be 0 because mod is given here. So remainder should be 0, means it accept what? The even number of A's and B's. So what are the alphabets in the language? A or B, okay. So it is same as the previous example, but instead of the odd number of A's and B, here you are going to accept what? The even number of A's and B's here. So first step is what? You should write the valid string list. See, if I take a 0 mod 2, what I get? 0. So which is there in the language. Next, 1 mod 2, what I get? I get 1. 2 mod 2, what I get? I get 0. So 2 empty string is valid. Next, the string with the length 2 is valid. Next, the string with the length 4 is valid here. Okay. So these are the valid strings in the language. So I'll write here valid strings. Valid strings are, the empty string is valid. Next, the string with the even size. So it may be a same character AABB, or it may be AB or BA. So all these are valid because the length of these strings are 2, and 2 mod 2 you get what? 0. Next, AB is valid, length of string is 4 here, and 4 mod 2 is equal to 0. Next, you take a same character 4 times. So these all are valid strings here. Next, the string of size 6 is also valid. Okay. So on. So all these strings are there in the language. Next, the invalid strings. So what are the invalid strings here? If 1A occur or 1B occur, that is invalid because the length of the string is 1. Next, if 3, the length of the string is 3, then it is invalid. Next, 5, 7, if the length of the string is 5, 7, which are made up on a A's and B's only, those all are considered as a invalid strings. So second step is what? I should draw the basic DFSM. So what is the minimum string accepted here? It is a epsilon. After that, you are going to accept what? The strings of length 2. Okay. So as the epsilon get accept, the start state of the DFSM is a final state. See, without anything, you are reaching the final state. So that is what you are going to start, and you are in the final state only. So if I draw a start state as a final state, it will accept what? Epsilon. Epsilon means the empty string. Okay. What is the next string to be accepted by this DFSM is AA. If one A come, it will change the state from Q0 to Q1. Okay. Next, if second A come, then where I should show the A ka transition from this Q1 state. Shall I take a loop? If I take a loop, it start accepting what? 1A. Okay. Next 2A. Then if I show 3A, 4A, 5A, then if I show the transition from this state to this state for any of the character, then it will reach the final state. So loop will not come here because loop accepts 0 or any number of A's and B's. So I will write here A or B. If one A or B come, change the state from Q0 to Q1. Next, from this state, if A or B comes, then change the state from Q1 to Q0. Check out. See, A occurs. So for first A, it will change the state from Q0 to Q1. If second A come, it will change the state from Q1 to Q0, and Q0 is the final state. So it gets accepted. Check for the BB also. One B it will move here, second B it will move back to Q0. Next A, B. Next BA, BA. Next A, B. So it start accepting the string of length 4. Okay. Next, it should not accept the string which are there in the invalid list. Check out for the first string A. If A come, it will change the state from Q0 to Q1, and Q1 is not a final state, not accepted. Check out for the B. It will change the state to Q1, it is not accepted. Next A, B, A. 1A, next B come, it will move to the Q0 state. When A come, it will move back to the Q1 state, not accepted. Okay, next B. So it moved to the Q1 state where Q1 is the non-final state. Next 3 A's, 1A, 2A, 3A, it will reach the Q1 state, so it is not a final state. So these are not accepted by your DFSM. So the difference between this DFSM and this DFSM is here we are accepting the odd number of A's and B's, where the second state is a final state because it accepts what? 1A or 1B. In this case, the length of A and B should be even, so I made the first state as a final state. Yes, you can make a start state and final state the same state only. Okay, that is possible. So this is about the DFSM. Next, you should represent this DFSM by 5 tuples where K equal to Q0, Q1. Next, the start state is Q0, the alphabet is A, B. So sometime they give alphabet only one, either A or B. That time you should show on a transition either A or B, which is given. Next, accepting state is Q0 itself. Next, the transition function. So here Q0 and Q1 state, A or B. So Q0 of A, you are going to move to the Q1 state. Q0 of B, again Q1 state. Q1 of A, you are moving back to the Q0 state, A and B. So this is a transition table for this. I hope you understood this problem. Thank you.